here's a picture. You might study why this equation is this picture in high school. But for now, let's look at a simpler equation like this. What kind of picture does it have? In this lesson, you will learn to understand proportional relationships by relating their graphs and their equations. Let's review what you already know about equations for proportional relationships. Here's a proportional relationship, $8 for 2 pounds of potato salad. You already know that the unit rate can be found by dividing. In this case, it would be $4 per pound. To write an equation, you pick a variable for the independent quantity, which is the number of pounds. And you would need to multiply that variable by the unit rate, by 4. 4W would give you the cost of any number of pounds. You pick a second variable to represent the dependent variable, the cost in this case, and you set 4W in this case equal to that second variable. So the equation is that the cost is equal to 4 times the number of pounds. There are a couple of common mistakes we need to be careful about. Suppose you're talking about 3 miles per hour, and suppose you use t and d as your variables for time and distance. Which one is the independent variable? Which one goes on the x-axis? Well, in a unit rate, the one that is the after the word per, the one that we have one of, is the independent variable. It goes on the x-axis. 3 miles per 1 hour. So time, or the number of hours, goes on the x-axis. One more thing to be on the lookout for. If you're writing the equation, which of these is correct? Be really careful that you multiply the correct quantity by 3. In this case, we want to multiply the number of hours by 3, since it's 3 miles per hour. So this is the correct equation. First, let's learn how to compare a graph and an equation to see if they're showing the same relationship. Here's an equation, c equals 4w, and here's a graph. There are a few ways to check whether they in fact show the same proportional relationship. One way, which is a bit slower, is to test specific ordered pairs. For example, here's an ordered pair on the graph, 2, 8. Plug those numbers into the equation. In this case, they do satisfy the equation. You should test a few more ordered pairs from the graph until you're satisfied that the graph and the equation represent the same ordered pairs. A different method is to use the unit rate. From the equation, we can see that the unit rate is 4 because it's the number that we're multiplying one variable by to get the other variable. Is 4 also the unit rate that we see when we look at the graph? Well, if we find 1 on the x-axis to see how much 1 pound costs, we see that it also comes out to 4. 1 pound costs $4. So both of these have the same unit rate, therefore they're the same proportional relationship. We can also talk about how to make a graph from the equation, 3 miles per hour, whose equation could be d equals 3t. T represents time and d represents distance. How can we make a graph of this proportional relationship? Well, you've already learned in the past that you can make a table of values and plot those values and connect them. But another way is to use the unit rate. From the equation we see, and from the statement 3 miles per hour, from both of those we see that the unit rate is 3 miles per hour. So we can use that to make the graph quickly. Find 3 miles and 1 hour on the graph and plot a point there. Also, since it's 3 miles for every hour, we can get additional points using the unit rate. 3 more miles would take 1 more hour, and then 3 more miles than that would take 1 more hour again, and again. That's how we can use the unit rate to construct the graph. In this lesson, you have learned to understand proportional relationships by relating graphs and equations.